Hello and welcome back to another video. And in our last video we discussed decision trees and how we can classify or simply make a decision tree based on a data set, and this is exactly what we worked on, and this is the code that we worked on. Now before we move on to the other models, it's very important for us to learn what exactly are classification metrics. Now how do you know whether your model predicted the data rightly? How do you know, well, your model was perfect at predicting the true as true or false as false? And that is exactly where that is exactly where the classification matrix comes in. And these are precisely all the formulas that this is like a table I copied from a book, and so this is exactly what it means to calculate whether the model predicted something right. And there are multiple formulas for calculating the accuracy or the misclassification rate or the true positive, false positive rate of your model, and I will be going through each and every one of them one by one. So let's move on, right? So first of all, we need to understand what confusion matrix is before we can actually move on to the much more important and a complicated part, which is the ROC curve or AUC. It's important for us to understand what confusion matrix is, right? Now, what is confusion matrix? Confusion matrix is simply just another matrix, except for the fact that you will be creating an n by n matrix. What is n by n matrix? What do I really mean by the n by n matrix? Well, it means that so let's say we had this decision tree that was predicting ones and zeros, right? So we only have two classes, so which means that our confusion matrix will be of 2 by 2, right? So we have two classes, so we need to actually create a 2 by 2 matrix. So our matrix will look like this, but let's say our model was predicting it was giving answers out of 3 classes. So let's say it was a multi-class classification task, so our confusion matrix will increase by 3 by 3, and then it will be different, right? So right now let's try to actually understand what this matrix really tells us, right? First of all, we're gonna go ahead and write positive and negative on the y-axis, and it's gonna say all the predicted values that our model predicted, right? So this is the answer that our model predicted. It can be either positive or negative. And similarly, we have actual values. So the actual values are either 1 or 0. So that is the one that we are using. So this is the y test right here. These are the actual values of our data set, right? These are the actual values, and that is the predicted one. That is our model. That's what exactly our model is going to predict, right? So now we can just go ahead and count those values, and we can just go ahead and put them and keep increasing the count until we get a final confusion matrix. This is exactly how we actually go ahead and create the confusion matrix. And now, how do we? What would happen if we could create a confusion matrix for the model that we have created right here, right? So let's just do that. So I'm just going to go ahead and see. So surprisingly, in Python we have confusion matrix built in using the scikit-learn library. So you can use the matrix library, matrix class from scikit-learn, and you can directly just go ahead and print the confusion matrix of your model. So I'm just going to go do ahead, and we need the predicted and actual attribute for that. So we have predicted actual, so you can just go ahead and put them directly inside our confusion matrix. So I'm just going to go ahead and say print and confusion underscore matrix, and then we needed to write this separately. So because obviously the format of this is, if I press shift and tab, you can see that it says that you need to put a y predict after the actual value. So that's exactly why I need to put a y underscore test before predicted, right? So if I just go ahead and predict this now, you can see right now it instantly gives us this answer, and from this answer you can kind of get the idea that the true negatives are 2 and the false positives is 1. So our true negatives were, let's say, 2, and it predicted it rightly, and one of them was actually wrong, and this is exactly what you can see here. So you can see that 2 of them are right and one of them was wrong, right? So this is exactly what our model tells us. Our model is basically capable of doing it. And secondly, we can actually go ahead and calculate the accuracy of a model. So how do we calculate the accuracy? Well, we can just calculate that by true positives plus true negatives divided by true positives plus true negatives plus false positives plus false negative, and we can just go ahead and put that in a formula, and we can directly get this answer. But surprisingly, in Python we have that as well, so you can just directly use this accuracy score for finding that out. And how do we do that? Well, we can basically we can just simply just copy and paste this, and instead of confusion matrix we can just go ahead and write accuracy score, and voila, underscore score, and I if I just do this, you can see this is the accuracy score for our model, which is 60%, which is not that good because obviously our model was not trained that well because we had a very small data set to, for it to train on. So we obviously have to obviously need a bigger data and much more data on which our model can see, and then that's exactly when our model will actually get much more accurate than this, right? So now you know what confusion matrix is and how we can actually go ahead and implement one in Python. We can move on to a much more better, or I can say another matrix that we can use to actually calculate, or exactly what basically data scientists use to actually judge a classification model, right? So what is an ROC curve? ROC is a probability curve that represents the degree or measure of separability. So what you can say is that how can we separate our true classes and false classes? So let's say our model predicted the true and false. So how do we know that our model predicted them rightly? So we can actually visualize that directly using this ROC curve. ROC curve simply just goes ahead and visualizes that for us. So I will actually go ahead and actually tell you what exactly this means. Don't worry if you don't understand this right now. Right now, if you take a look at this ROC curve, if you take a look at this graph right here, it is simply we have to simply just go ahead and put a true positive rate on the y-axis and false positive rate on the x-axis, and from 0 to 1. So that's exactly what the values from. So that's exactly where the values will vary. So these points are basically the points from true positive rate and false positive rate, and these are the points that we need to plot. And how do we calculate these points? Well, simple. We can just go ahead and put the true positive divided by true positive plus false negative, which simply yields true positive rate for us for every instance. And then we need to calculate the same for false positive rate, where we need to put false positive rate divided by the true negatives plus false positive, and we get these values. So for every instance we get these two values, and we simply just keep plotting them until we get all the points of the graph, and we simply just go ahead and draw a line over that, and that's exactly how we calculate the ROC curve of our matrix. Now don't worry if you don't understand right now, because I'm actually going to go ahead and show you this in the form of a table and how we can do this. So now what exactly is ROC? Well, the better the model is, so exactly how do you know that so from how you can tell whether the ROC was whether the ROC did the right thing or not, our model was accurate or not? How we can tell this by using the ROC? Well, it's quite simple. If the curve that we are getting is going to touch 1 right here, like 0 and 1, we can say that our model was able to predict the classes rightly. But what it means is that the model was able to predict the true as true and the false as false, right? So it's that simple. So let's just go ahead and start plotting this, right? So let's say we had a table like this. So we have a separate instance. So this is like the result that our model returned, right? So let's say this is the result that our model predicted, and let's see if whether this model whether this is right or not, right? So to do this, we can just go ahead and count the number of positives and negatives. So the true positives are, so let's just say we can mark a line right about here, and then we can just go ahead and draw a table like this. So 3 positives, 4 positives, 2 negatives, 4 negatives, and then we can just go ahead and count it. So how many true positives are there? So what our model predicted and what is actually is true positive, that is 1. And what about the false positives? Well, there is none, because we are marking it right. We are marking the line right about here, so there is none. So we can just go ahead and put 0, right? And then we can just go ahead and check all the answers beneath the line, beneath this marker right here. This is an imaginary marker that we are assuming like that's right here. So we can just go ahead and count the number of true negative. So how many of them are negatives, and they're actually negatives? So we can say 1, 2, 3, 4, and 5. So we put 5 here. What about the false positive? What about the false negatives? Well, the false negatives are 3 because we can count them. We can see 1, 2, 3, and 4. So you can just see that is exactly what we have, 4, right? And then we can just go ahead and use these formulas that I've showed you above, and we can put these values in these formulas, and we're gonna get these values: 0.200, 0.40. You can calculate this. Now I'll leave this as an exercise for you guys, so you can just go ahead and calculate these values further. And once you get all these values, you can just go ahead and directly plot them similarly to how these values are plotted right here, and you're gonna get a graph kind of like this, right? So now how do we know whether our model was good? By seeing this graph. As I mentioned earlier, the more the graph reaches this point, it means your model was good, right? And the more your graph reaches the diagonal point, which is which is this line right here, this is the diagonal, so it means that your model is not good and it's very incapable of distinguishing between the yes and no's, right? So from this you can go ahead and see this point right here, and you can instantly tell that this is the best our model can get. That is 0.54. Obviously this is not the graph from this table, and this is exactly why I'm leaving this as an exercise, so you can just go ahead and make a graph or draw a graph for this table right here and check if what you get and what is the accuracy that you get from this graph, right? And then how do we draw the ROC curve? Right now these are all these points, and then you just follow these points. How do we draw a curve from this? Well, you can just go ahead and use the concept of convex hull, which simply just goes ahead and you can just go ahead and pick all the corners of this or simply the edges of these points and draw a curve like this, and this is exactly what an ROC curve looks like, and you can see that this is the curve that we get, right? And now so this is exactly where we come to the point where what is the area under the curve. So the area under the curve is all the area that is inside this curve. So what I mean by this is that the more your point touches this point right here, 0 and 1, the more better your model is. And similarly, the more area you have under this graph, the better your model is. So this is exactly what area under curve means, and you can see so area under curve is simply the curve beneath your convex hull curve right here. See, so what do you mean by the AUC1, AUC2? So what I mean by this is that if your area under curve is 1 is equal to 1, it means that your ROC curve touches this point right here. And similarly, if your AUC is equal to 0.5, then your ROC will simply be a diagonal line. And if your AUC or area under curve is equal to 0, the ROC will simply just go ahead and touch this point right here, which means your model was basically reciprocating the values. So if it was 0, it was predicting it as 1, and if it was 1, it was predicting it as 0. So this is exactly why your AUC was 0. So now in Python, we're just going to go ahead and implement this, right? So how do you implement this in Python, right? First of all, I'm just going to go ahead and import few libraries that I need. So first of all, I'm just going to go ahead and import an ROC Curve library from scikit-learn, which is a part of scikit-learn, right? So I'm just going to go ahead and say from sklearn.matrix import, we can see ROC underscore curve, right? So this is exactly how you import ROC curve. And the second thing that we need to import is the ROC curve score, because we also need to calculate the score as well. So sklearn.matrix import ROC underscore accuracy score, right? So this is exactly what AUC score means, and this is just going to return an answer in a form of points, and we will simply see how we can use these libraries to calculate our ROC curve or even plot our ROC curve. And this is exactly what we're going to do. Okay, so now we're going to be using the same model that we have right here. So this is the model we have. This is the model I have. So I'm going to be using the same model, right? So how do we do this? Now the first thing we need to do is going to be pretty simple. We just need to go ahead and simply calculate the probabilities, right? So probabilities equals model dot. So now model is our model that we created above. So this is the decision tree model that we created. See, this is the model, right? So I'm just going to say, and then we have a function called predict underscore prob. So model dot predict underscore probability. So this is simply the function, which is simply I don't know, this function is not, the name of this function is not that good obviously, but you got to remember that. And then we can just go ahead and pass in the x underscore test values. Now that is the test input, right? So I'm just going to pass this, and then I'm just going to go ahead and print this probability. So the probabilities are going to be, so you can see the probabilities for every single input set we have is kind of like this. So the probability is 0% and 100%, 0% and 100%. That's how you predict the probabilities, right? And now we can just go ahead and just take, let's say, the first probability of our graph. So we can just say prob equals probs, and we can just say all rows, and I want the 0th probability. So if I just go ahead and print probability now, you only have the first one, so that's the first one right here. And then we can just go ahead and let's say I wanted to calculate the AUC score, right? So what we can do for that is we can just say AUC equals, which is just a variable name, and I can say ROC underscore AUC score, and then the AUC score receives two things. So it receives the true outputs, which are actual outputs, and the scores. So the probability score that we calculated right here, right? So I can just go ahead and say y underscore I can say y underscore test, and then I can put the probs that I calculated, and this is going to return the AUC score. I forgot to print this out. So if I just put AUC right here, you see that the answer is 0.5. So this means that that our model was basically incapable of predicting between zeros and ones, and it's totally fair because we did not give it an enough data set to train on. This is exactly why we are getting such a low AUC score, and from AUC score 0.5 you can kind of tell that our model was basically a diagonal line on ROC curve, and you will see this when we will actually plot this, right? So I'm just going to go ahead and plot this now. So how do we plot this? So for plotting, you definitely know that we need TPR, we need FPR, and we also need the ROC curve, right? So we need the threshold, we need the TPR and the FPR, right? So I'm just going to go ahead and do that. So for that, we can just go ahead and say FPR equals FPR, comma TPR, and simply the threshold. So I'm going to call that as thresh, and equals ROC curve, which is a scikit-learn function. That's a predefined function, and this receives two things. First of all, it receives y underscore test, and it also receives the probabilities, right? So we just go ahead and put the probabilities right here. And now if you just go ahead and print out the false positive rate, you can see that it just simply goes ahead and calculates exactly the table we needed. So this is the table that we wanted, right? And it calculates exactly those things. So now from this you can kind of tell that we can just directly put them in a graph, and it's going to go ahead and print the probabilities for us, or simply print the ROC curve for us, right? So I'm going to use the matplotlib library. I hope that if I have imported that. No, I haven't imported matplotlib, so I need to first import matplotlib. Import matplotlib dot pyplot as PLT, right? So if I just import matplotlib, it's going to take a little bit of time. So we have imported this. We can go down, and now I'm just going to go ahead and say, well, simple PLT dot plot, and first of all we need to draw a diagonal line. So we're going to draw a diagonal line from 0 to 1, and we're going to also draw a line from 0 to 1 which approaches 1 and 0, right? So this is exactly what I'm going to do. And then I can say, well, since I want to draw this, so I want to draw this in a form of dotted lines, right? So I'm just going to go ahead and draw the dotted line. So for that I can just go ahead and put a style as dotted, right? This is exactly how you draw a dotted line, right? So if we do this, you can see that I have a perfect line right here, and now we can just go ahead and plot the false positive rates and true positive rates on this graph, right? So for that, what I need to do is I need to say plt dot plot, and well, what we need to do, we can just go ahead and say fpr tpr and comma. So what is the marker here? So I'm just going to go ahead and use a marker as equals to, let's say I put a dot right here, okay? And if I do that, you can kind of get the idea right here that it doesn't just change the color here, because obviously we cannot get the idea here. So I'm just going to change the color to red, and you can see well, since we have the diagonal line on orange, you can see that this is exactly what we wanted to achieve, right? So you can see that the answer is simply a diagonal line, and we know that our model was simply incapable of distinguishing between yeses and nos, and it's simply a random guess, right? So we obviously need better data and more data, right? So this is how you actually go ahead and draw an ROC curve. Now let me just go ahead and give you a very quick example of how we can actually go ahead and do this for a bigger data set, and how this will change for a bigger data set, right? So for that, I have an example right here that I prepared for you guys, right? And so I have this make classification example. So I'm using this make classification right here, make classification function, which is simply using 1,000 samples, and we only have two classes, which is going to be either 0 or 1, and then we simply just go ahead and train and test these on the examples, and we finally get what we needed, right? So I'm just going to go ahead and change this to x underscore train and x underscore test and y underscore train and y underscore test, right? So now if I change this to this, well, it's pretty simple. Right now what we need to do now is we can just go ahead and first of all we need to import the make classification function. So how do we import the make classification function? Well, it's simply a part of the dataset libraries from scikit-learn. So I can say from scikit from sklearn dot dataset import make classification. Now this function right here is capable of creating random data sets for us, so we don't necessarily need to use an actual data set. We can just go ahead and use this domain data set to test our accuracy, or simply just learn whether this ROC curve changes or not for a different data set, right? So we can just do that, right? So awesome. So we can just go ahead and copy the same code from here, and I'm just gonna go ahead and say well like this, and then I'm gonna plot this. Okay, so now we have an error. It says alright, so we have an error. What is the error here?